Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good evening. So my name is AMSYAR bin Ibrahim and we are from group 8 and other member are Lim Junji, Muhammad FAIZ HAIKAL and AHMAD FIRDAUS. So for this robot, we are going to present robotic arm design for car body painting and its process. So let's start with the next slide.
I'm gonna start with project overview. My name is FIRDAUS bin KAMARUDDIN. So we're gonna talk about in recent years the use of a robotic system industrial application has grown very rapidly, especially in field where the precision and consistent are critical. Which one of it is automated spray painting. So so currently, traditional method where we use human labor to manually painting can lead into inconsistency and can lead to inconsistency and errors and safety issues due to exposure to chemicals. So our main project, next slide please, Amshah. So our project aim to address these challenges by designing a robot arm system that automate the painting of car bodies. So first, our main objective is to design a robotic arm configuration that offers sufficient reach and movement flexibility to cover the full surface of the car body. Secondly, we aim to construct a 3D CAD model of the arm, complete with realistic joint actuators to simulate how it would function in a real-world environment. Thirdly, our objective is to develop the forward kinematic model using DH method or Dinavit-Hartenberg method. And lastly, we want to simulate the painting operation using software to visualize and optimize the robot motion path. Okay, that's all for me. Next.
Good evening, Doctor. My name is Lim Junyi. So right now I will bring you through the methodology of this project. First, we go through about, in this methodology, we have type of robotic arm. We also go through the robot itself, the robotic arm design, and kinematic calculation. Next. Okay, so first is the robotic arm type. In this case, we choose the articulate 6DOF robotic arm. The reason why we choose this 6DOF articulate robotic arm is because, as we all know, painting the car, right, is very complex. Therefore, this 6DOF able to help us to paint the car in large workspace coverage and also offer the high flexibility and precision. Next. Okay, so for the robot work cell, we choose inline robot work cell because it allows car to move on the conveyor through the paint booth. Also, it offers precision and consistency. As you know, they can apply the paint with consistent thickness, evenness, and spray pattern. Also, it increase the productivity, efficiency, and improve the quality and consistency. Next. Okay, so for the robot arm design, this is a 60F, and each type of the joint is revolute joint. For the first joint, is base rotation, and it rotates about the z-axis. For the second joint, is shoulder, and it lifts the arm. And the third joint is the elbow joint, and it also pitch extend the arm. For the fourth joint, is wrist joint, is roll along the x-axis rotation. The fifth joint is pitch, it rotation around the y-axis, and the last joint, which is the sixth joint, is wrist tree, and it's also roll along the x-axis. Next.
So next part is me. So for the robotic arm design, we have a few features. The first one, the main is seat revolute joint for full rotational motion, and then we equip with several sensor like encoder, proximity sensor, and spray flow sensor. For the encoder, usually we put at the joint uh, of each joint. For the encoder, we put at each joint to get the value for the rotation and the degree of the movement. And for the proximity sensor, we put is to distance the spray between the spray and the car and to avoid the disturbance. And lastly, spray flow sensor at the sprayer. And this is the two orthographic of the robotic arm. We have 3 view and one isometric view here. The software we use to design this is Shaper 3D instead of SolidWorks.
Okay, my name is Muhammad FAIZ REZAL. So I want to explain about the forward kinematic calculation DH. So the Dinnervit-Hittenberg DH convention is used to describe the kinematic of a robot arm. So the DH parameter is a set of 4 parameters, which is joint angle theta, link offset D, link length A, and link width alpha. So this parameter is simplify the mathematical representation of the arm configuration. So from this calculation, so we must find this table, which is of the joint, because we have 6 joint. Okay, so we must find the theta values, which is the theta value is each of the joint. We will assume the joint angle theta will change based on the movement comment. So and also after we define the table, and we use the formula, which is the transformation matrix A for the each joint is given by the formula. So after we find, and then we substitute to the formula, and then also we find the A1, A2, next slide, A3, A4, A5, and A6. After that, we conclude to the final, next slide, to the final transformation matrix, which is we find the T transformation. So we can see that for the T final matrix, transformation matrix, which is I simplified for the, we assume the R1, R11, R12, R13, and PX. So overall, that value on the matrix we calculate, and then we summarize into 4x4 matrix for the final transformation matrix. That's all.
So next part, let's move on with the simulation. Okay, so we are using a 2 robotic arm, and for the path planning, we're using a zigzag movement. So you can see it move line by line. So that's all for the simulation.
Okay, since we are already come to the end of the slide, so I would like to conclude our presentation. So far, this project demonstrate the effectiveness using robotic arm, robotic automation in car body painting application. So we have successfully designed a seat the degree of 6 degree of freedom articulated robotic arm, where we use Sharp 3D software to show our design and our path planning. So for the future, I think we are for future outlook, this robot can be improved by adding a real-time feedback such as vision system, laser scanners, and we also would like to, we are able to improve, we need to simulate the environment effects such as airflow, temperature, paint dispersion. So overall, this project highlight the strong potential of combining mechanical design, kinematics modeling, and simulation software to solve real-world industry challenge. So I think that's all. That's right. Thank you from us. Thank you for your attention. That's all. Thank you.